So the question asks to find the area under the curve between 2 and 8 of the following function. So we can rewrite this as the summation of the rectangles filling up under the area of the curve as the number of partitions, which is represented by n, goes to infinity. So the area of the rectangle will be written as delta x multiplied by the y, which is f of x. K is just which partition it is. So we need to re-express these two because we know the f of x, but we need to re-express these ones. So delta x can be written as the difference between the x's, so that's 6, over the number of partitions, which is n. So xk can be written as, since we're going to do the right side of the rectangle, like right side, so it's going to be the beginning x, which is 2, plus k, which is the number of partitions so far, and multiplied by the size of the partitions, so 6k over n. So we're gonna rewrite the limit, but we're gonna substitute the xk into the function and multiply it by this. So limit as n goes to infinity. So this is a constant, as we know, so we can take it in front of the summation. So 6n multiplied by the sum as n k equals to 1. So 5 times x squared. So this is squared, so 5 multiplied by, first it's 2, so it's 4. 4 plus 4 times 6, 24 over n. I'm writing it like this so I can take it, once I expand this, so I can take this outside. Plus 36 over n squared times k squared, plus, I don't have enough space, but 4 multiplied by 2 plus 6 over n. So it's like this. So we can rewrite the limit, but now we can take the constant outside and then expand the summation as each term. So 6n, we can actually multiply this here, so 30n multiplied by, just do this. So first the sum of this, so k equals to 1, and so 4 plus 24, so we're taking out the constant, multiplied by the summation of the k's, plus 36 over n squared, summation of n, k equals to 1 of k squared, and then this is closed, plus 4 times 6n, so that's 24 over n, multiplied by the summation of the 2, plus 6n, okay, so 6n multiplied by the sum of the k's. Sorry, it's not enough space, but get the idea. So now we can just save a line and just see what this equals to. So this is going to be equal to 4 plus 4 n number of times, so that's going to be 4n. Then, okay, we have a special formula for that, which looks like plus 1 times n over 2. It's going to be this. The k squared always looks like n plus 1, 2n plus 1 divided by 6, and this is 2n, and the last one is the same as this. I'm not going to rewrite it because it's the same. But now we can multiply through. So limit as n goes to infinity of 30n times 4n, so it's going to be 120, n cancels out, so 120, plus we have 24n times this, so n's can cancel out, 2 can cancel out, this is going to be 12, so you're going to get 30 times 12 is going to be, I believe it's 360, times n plus 1 over n. So this, as n goes to infinity, is going to go to 1. Because n over n, 1's not going to count at infinity, so. And then the last one of that part is plus 36 n squared times n. So we're just going to take this away, so n. 36, 6, so it's going to be 6. So it's going to be 30 times 6, which is 180. And then you're going to get n plus 1 multiplied by n, 2n plus 1 over n squared, because there's one n here, and then there's n over there. So this is n, so it's going to be n squared. So this is going to go to 2 because of the constant in front of it. So it's going to be 360. And then the last part is going to be, okay, 2n times 24 is going to be 48 plus 6n, n cancels out, 6, and there's, I believe there's divided by 2, so 3 times 24, I believe that's 72, multiplied, and then again you get the n plus 1 over n, which goes to 1, so times 1. So we can rewrite this as limit n goes to infinity as 120 plus 360, 180 times 360, plus 48 plus 72. So limit n goes to infinity of 960, which is going to equal to 960. So the area under this graph from 2 to 8 is going to equal to 960.